This is part 1 of our video on exponential function review. So our first question says, for the functions f of x equals 3 times 4 to the power of x, and g of x is e to the power of x, evaluate, and then the very first one we have here is f at 10. So evaluate means we want to calculate and actually get a number as our answer. So when we're doing function notation, this number here, the 10, goes in place of x in our function. So everywhere I see an x, we are going to put in the number 10. So f at 10 is going to equal 3 times 4 to the power of 10. I'm just going to do that on my calculator. So 3 times 4 to the power of 10. And I get 3,145,728. Our second question says f at -2. So for this question, everywhere I see an x in our equation, we are going to put in a -2. So this is going to be 3 times 4 to the power of x, or -2. Now, next to this question, it does ask for it to be a fraction. So I do not just want to put it in my calculator and get a decimal. A negative exponent makes a fraction. So on our identity sheet, there is a place here that says b to the -x equals 1 over b to the x. So a negative exponent makes something a fraction. The base, it flips the base over. So this is going to become 3 times 1 over 4 to the power of 2. When I have 1 over 4 to the power of 2, there is a rule on my sheet that says if you have a fraction to any power, that power applies to both the numerator and the denominator. So 1 to the power of 2 is 1, and 4 to the power of 2 is 16. Last thing I need to do is multiply these together. When we multiply fractions, we do numerator times numerator, denominator times denominator, or top times top, bottom times bottom. Underneath this 3, there is a secret 1. So when I go to multiply, I'm going to do 3 times 1, which is 3, and then 1 times 16, which is 16. So our final answer here should be 3 over 16. All right, our last question says g at 4. This is a different function. If I take a look in the question, it said g of x was e to the power of x. That's odd. So g at 4 is e to the power of 4. Now, e is a transcendental number, meaning it's a number that just goes on forever, that is very similar to pi. So e is Euler's number. It looks like Euler, but it is Euler. And it is a long decimal that just goes on and on and on and on and on. Now, on your calculator, you should have the ability to calculate e. So on most calculators, there's always an exception. If you can find your ln button, so that's the one that says ln, it should be the second function or the shift of that button. So I see ln, and then above it in orange, I see e, and then to the power of x. So just out of interest, e to the power of 1, on my calculator, I have to put the exponent first. I would do 1, and then I would do second, and then my ln button to do that. This is what Euler's number is. So it's 2.71828182, and it looks like it is repeating, but then it goes off the rails after that. My calculator just can't show enough decimal places to show that. So if I wanted to do e to the power of 4, on my particular calculator, I have to put 4 in first, and then shift, and then that button. If you see what you type in, so if you have a calculator that has 2 lines on the screen and you can see everything that you type in, you probably want to do the second function e of the x first, and then put in your exponent. So I will show you on this one. So on this calculator, it's a little hard to see, I have a lawn button. It is right here, and then above it in blue is my e to the x. So on this one, if I turn it on, I would do second and then my lawn button, and there's that e to the x, and then I would put the 4 in. So it just depends on what type of calculator you do, what order we're going to do it in. And for both of them, I got the same answer. So this is approximately 54.60. And the question did ask for us to round it as a decimal to 2 decimal places. Okay, so I will see you in the next part of the video to talk about question number 2.